Thank you, Kyle, for that introduction. I always forget that I should shorten my bio and people have to read the whole thing, so thank you for doing that. So I'm going to talk to you all today about sustainability, which is a broad topic, and hopefully we'll kind of cover more than just beef, but talk about sustainability in general. But of course, we're kind of focusing in on how does beef cattle or beef production actually fit within a sustainable food system. So just to get started, you're in Iowa, right? So you're probably a little bit familiar with the cattle life cycle, but I like to lead with this just because a lot of the stuff that I'm going to talk about in the rest of the presentation kind of comes back to this life cycle and using some of the terms that are on the slide right now. So within the US, this is actually the simplified version. We're not considering dairy in this situation, but essentially the beef production system is broken up into three phases. So we have cow-calf production, which is primarily grazing-based operations, where there's the mother cows, and they're going to have a calf ideally once per year. Okay. So then those calves that are raised with their mothers are going to get weaned, typically around 550 pounds. Okay, and they're going to be somewhere between 6 and 8 months old. And then from there, those animals can actually move on to the next phase of production, which is what we call stock or background production. So those are different terms. They're used in different parts of the country, which makes it all a little bit more confusing. But these operations tend to be where animals gain more weight, but they're eating a forage-based diet, or in the case of stocker operations, they're grazing more grass for the rest of their life. From there, cattle will move into feedlots, which you just heard mentioned. Iowa has the greatest number of feedlots, actually not the greatest number of cattle on feed, or that's our term that we use for feedlots, that's Nebraska. But this is where animals are going to actually eat a diet that contains grain, right? So when you hear about corn-finished beef, grain-finished beef, this is where grain is going to be a constituent of their diet. Not their whole diet, usually around 55-60% of their diet will be grain at this part in their life. Or alternatively, cattle can be grass-finished, right? So when you hear about those two different production systems, grain-finished or grass-finished, really the difference comes in that last third of their life when they're in that finishing phase, right? So the rest of their life is similar throughout the rest of their life cycle. So just that little bit of background before we get started. So sustainability, what is it, right? What does it account for? It's a complex topic, right? Pretty universally accepted is that sustainability accounts for three different pillars, if you will, or I like to think about it as a Venn diagram approach. So we have economic issues, social issues, and environmental issues, right, that all make up sustainability. So that can be issues as varied as, can people afford food, right? We know even in the United States we have a lot of people that are food insecure or have not the right amount or can have food available to them all the year for affordability reasons or whatever that may be. To things like the viability of rural economies, right? That's important for sustainability. And of course, nutrition, right? Nutritional quality is a part of sustainability. And then we have all the environmental issues that we kind of think about as akin to sustainability, or often it's made equivalent to sustainability. This really is just a part of it, right? So things like carbon footprints, water footprints, land use, all those type of things that are important for sustainability. So I put this up here. If you can't read all the words on the screen far in the back, mainly the takeaway is it's complex, and there's areas where these different parts of sustainability overlap, right? Economic issues overlap with environmental issues, right? And so there's trade-offs and synergies that exist with all these things. So it is a complex topic. There is no simple answer, no one-size-fits-all answer when we're talking about sustainability. So with that said, I think this is an interesting concept and probably something that you all are kind of familiar with because you interface with people and food all the while. This is an idea that was put forth by a professor at Purdue University, Dr. Jason Lusk, who's an ag economist, and thinking about how these food issues are kind of a little bit getting more contentious, if you will, right? And I'm kind of preaching to the choir, right? You guys deal with this all the while in terms of how people view food or think about food, right? And how their values are brought to the table. Sorry for the bad pun, when they're thinking about food decisions, right? So what this is on the screen, you're probably all familiar with the idea or the concept of Maslow's hierarchy of needs, right? We go from our basic needs at the bottom of the pyramid getting up to the top of self-actualization, right? Who am I, what am I doing, right? That kind of thing. So if we think about that overlaps with food, as people get more prosperous, as societies get more prosperous, we're able to think about more of those things beyond just, am I getting enough calories today, right? Can I meet my basic protein needs? Some of the basic nutrition stuff that you are all dealing with, and now we're adding in, how is this actually produced? Does it align with my values, right? Am I the kind of person that would eat this food, right? And those are real concerns that people have as we think about modern society. And I put this up here mainly because, not that I'm telling you again anything you don't know, but this issue is not going away, right? The competing differences that you all have to balance when you're thinking about the food decisions people are making, it's just going to continue to exist, right? Everybody's not going to agree. It's going to get more fractured, and so we're going to have to balance all those different ideas when it comes to food. So that's kind of the broad overview of, it's a contentious issue when it comes to sustainability, right? It's not one size fits all, and it's not simple. The other thing, and you probably heard a lot about this last night, right, with the Food Evolution movie, is we've all heard that the population is growing, right? We're at about 7.7 billion people on planet Earth today. The latest UN projection is we're going to hit 9.8 billion in the next 30 years, right, by 2050. So people are going to consume a lot more food, and we only have one planet Earth, right? And that's kind of the fundamental challenge with sustainability, is how do we feed everyone without eating the planet while we're doing it, right? So along with that is something that is taking place, is people are getting more prosperity, right? They are getting more income. And so one of the first things that people do when they get more money in their pocket is they improve their diet quality. And that usually means eating more animal source foods, right, around the world. So this chart here is just looking at availability of the three major terrestrial, if you will, animal proteins. I'm not considering seafood, but looking at poultry and pork and beef in terms of how much is available per person per day in the world over the last 50 years, okay? So if you can't see the scale on the bottom, essentially it's going from 1961 to 2016, and we have kilograms available per person per day. So the yellow color, that is beef, has actually been flat, which always kind of surprises people, is the amount of beef available per person per day on average. It's been pretty flat over the last 50 years. So beef production has increased, but it's increased pretty much in sync with human population going up. What's really changed are both poultry, chicken meat, and pork, right? So those are the other two lines that are increasing rapidly. Right? So those, what we call monogastric animals, have grown rapidly in terms of how much is available per person per day. So we talk about meat consumption increasing. I always think it's important just to put this disclaimer on there. Even though I work for beef, it's not beef that's growing tremendously, right, per person. It's actually pork and poultry. And this chart is more just partially because I'm a nerd and I think it's cool that the USDA has food availability data that goes back to 1909, right? But this is looking at all the different animal proteins that are out there in the United States and how much is available per person per day, right? So availability is not a perfect metric for consumption, but it's kind of the best we have from a standpoint of going back this far. So a lot of different colors on the screen. The main takeaway is that beef consumption, remarkably, is pretty much where it was in 1909. Right? So beef consumption per person increased in the mid-70s. It's declined since then, so we're around 1.8 ounces per person per day in terms of beef. So that's been pretty remarkably flat. Total red meat consumption is also pretty close to where it was, down 3%. Again, it has declined in total since the mid-70s. What's really increased and why total meat consumption has increased is similar to what I just showed you from a global perspective, right? It's actually chicken in the United States that's really grown. Pork has been pretty flat over the last 100 years in the United States. So I just put this out there just as the context, right, of like, what are people consuming in the United States when it comes to meat, and this whole issue of animal agriculture and sustainability. So even though I said sustainability is complex, it has all these different areas that we're thinking about. Usually when you read news media articles about sustainability, it gets boiled down to like carbon footprints, right? And so I want to spend a little bit of time to kind of get get some explanation there about some of those differences that you may hear about with regard to carbon footprints of different animal proteins. So this chart that's on the screen is actually from the UN Food and Agriculture Organization, and these are global averages of carbon emissions, or greenhouse gas emission intensities is what we would call them. So that is all the greenhouse gases that get produced per unit of production, right? In this case, per unit of protein for all these different animal proteins, okay? So there's lots of greenhouse gases. I won't go into it. There's methane, nitrous oxide, carbon dioxide. Really the ones from agriculture that we're worried about is methane and nitrous oxide. And they have higher potentials to trap heat than carbon dioxide. So we put them all on an equivalent basis and can compare. So the main takeaway, or a couple of the main takeaways here, is when you look across, if you can't see the writing at the bottom, on the far right is beef, right? So beef does have a higher carbon footprint on average as compared to the other products which are listed, which going from right to left are beef, cattle, milk, small ruminant meat, that is goats and sheep, right? Lamb and goat meat, small ruminant milk, pork, and then chicken meat and chicken eggs, okay? So a lot of these differences are actually explained by the biology of the animals themselves, and I'll come back to this later in the presentation, but what it means for an animal to be a ruminant is they actually belch out methane gas naturally every day, right? So that factor combined with the fact that, of course, cattle live longer than chicken, right? Chickens are usually slaughtered at 6 weeks old, right? So that makes a huge difference in terms of greenhouse gas emissions that actually get produced in the total life cycle. And so that's why it's biology, right, that explains some of these differences between carbon footprints across the species. The other thing is there's a lot of variation. So these are box plots, right? They're showing you the variation that exists out there. And especially with beef, there's huge variation in carbon footprints around the world. And I'll come back to that again too later in the presentation. But mainly in the United States, we have one of the lowest carbon footprints in the world. And we have other parts of the world that are 10, 50 times higher than the United States. And I'll explain that a bit more, but it's really, it comes down to the number of live animals that are within the country versus how much beef they produce. Again, because they belch out methane every day. So, we're talking about trade-offs with sustainability, and this whole methane production process really is a trade-off with what we call upcycling. And that's what cattle are doing in our food system. So upcycling, you all may be familiar with upcycling from like a Pinterest page, right? And like upcycling old furniture or something, okay? So not that kind of upcycling, but essentially what we're talking about is the same concept, right? You take something that is of little or no value, and you make a higher value product, right? Not recycling and making something with equivalent value, upgrading it. And really that's what cattle are doing within the food system, okay? So they're taking plants that we cannot consume, right? Grass, hay, a lot of residues, right? Especially around here, you'll see a lot of corn stalks being grazed by cattle. So they're taking those inedible materials and upgrading it to a higher quality product, right? And so you guys can see at the top there, kind of that flow. I mean, it's all about solar energy, right? That's kind of a duh moment, but everything that we do on Earth depends on the sun, right? And so it's just, how can we capture that solar energy in an efficient way? And ruminants add a value proposition there because they're able to take solar energy that's unavailable to us, right? In those inedible plants and make a higher quality product. You also notice up top, the numbers that are on there. So 1 pound of human edible protein that we feed cattle in the US on average makes 1.19 pounds of human edible protein in the form of beef. You may be wondering, how the heck is that possible, right? How can you make more of something than what you put in? And that really comes down to what cattle eat, because they're not eating a lot of human edible stuff, but they're able to convert it to something that we do want to consume, right? And all the other products that come from cattle besides beef, whether it's leather or all the pharmaceuticals and everything else that we get from cattle. So that ratio is possible because what's in the bottom part of the screen there, that donut chart. So what that is showing you is information from the National Academies of Sciences of looking at the whole life cycle, coming back to that first slide I showed you, where we have cow-calf, stocker, the finishing, right? What do cattle actually eat over that entire lifetime, okay? And so that's what the donut chart is showing you, is about 80% of what they're eating is actually grass, forages, right, hay, over their whole life. Another 10% are what we could call leftovers, right? What we call in the industry byproduct feeds, but they're essentially plant leftovers. So especially here in Iowa, we have lots of leftovers. So when we process corn for ethanol, we get dry distillers grains, right, that can be fed back to cattle, essentially a waste product from that process. There are lots of examples of waste products from food processing, right? So out in Colorado, where I live, there's lots of sugar beets. And so when those sugar beets get converted, or we make sugar from them, we get a lot of pulp that gets left over, that gets fed back to cattle. It's an inedible product. And things like cottonseed, right? So we all like to wear cotton clothing. Actually, now I feel like you can't find anything that's 100% cotton, right? It's all has some synthetic stuff in it. But when we think about cotton production, there's a seed that gets left over, and that's actually a really good cattle feed for both beef and dairy cattle. So those are just some examples of those leftovers, essentially taking waste from other industries and making something of higher value. And then finally, that 9-10% that's left over, that's what the actual grain is in the animal's diet. So we don't feed a lot of soybean meal really at all to cattle, beef cattle in the United States, more on the dairy side, but it's mostly grain. And I just want to point out again, when we think about grass versus grain finished, the only difference really is that little sliver, right, of the 9% of grain. So more than 90% of what they're eating cannot be consumed by people. They're not really competing for the human food supply. So this is the trade-off. They're doing this amazing service, right? They're eating things that, again, pigs and chickens can do some of this, but they're not as good at it because they're not ruminant animals. But because cattle are ruminants, they make methane gas, okay? So I've been using this term ruminants. What that actually means, right, is their stomach is much different than yours and mine, right? So it's a large stomach and has 4 compartments. And the first compartment is called the rumen. That's why we call these animals ruminant animals. So goats, sheep, and cattle, or farm animals, are all ruminants. Deer, bison. Fun fact, the giraffe is the world's largest ruminant, right? So there's all sorts of ruminant animals that are out there. And this rumen in cattle can be 40 or 50 gallons in volume, okay? So that's like the size of your bathtub, all right? And this stomach essentially is a big fermentation vat. So these animals eat all this inedible stuff, and there's trillions of microorganisms that live within the rumen that are able to break it down, okay? Able to ferment it. You guys are probably very familiar with fermented foods and beverages, right? One of the byproducts of that process is gas, right? Gas. So both carbon dioxide gets released and some methane gets released. So about once a minute, the cattle have to remove that gas, otherwise they could bloat, which is a bad condition for cattle. And so I always say this is like the one takeaway for this entire presentation, right? I know it's a lot of science first thing in the morning, but if you remember as cow burps, not cow farts, then that's my job is done, right? So it all comes out the front end of the animal, okay? It's not cow farts. If I could see that never again written in a news article, my job would be done. The other misconception is that when cattle eat corn or grain, that they make more methane. It's actually opposite. So when cattle are in that feedlot situation, they're eating a grain-based diet, they decrease the methane emissions that they produce. So the more starch, the more fermentable carbohydrates that they have in their diet, the less methane they make. And when they are consuming more forage, they make more methane. And so that's what I did before I came to NCBA, is I directly measured methane gas. And so I have a lot of experience of doing this. Again, because it comes out the front end of the animal, it's not that bad of a job, but that relationship is very strong between what the animals eat and what they produce. So the second thing I'd like to talk to you about when it comes to these environmental issues is around land. Right, so you'll sometimes hear about how much land it takes to produce beef, but what's really important there is more of the context. What's important for all these things is the context. So beef cattle, they use more land than other species, but that's because they're expanding the land base that we really have available for us to produce food. And oftentimes they're enhancing the ecosystems while they're doing it. So what do I mean by that? This map that you're looking at right now on the screen is from a group called the American Farmland Trust. So they're very interested in the loss of farmland, loss of prime farmland around our urban areas, right, suburban development. And we unfortunately lose a lot of farmland. And that's what those red splotches are all over the map. The other land use types that are on this map, in the eastern US, more of that kind of grayish color, that's our forest land. Right? So unsurprisingly, in the eastern US, we have a lot more trees. The dark green, like what is covering most of the state of Iowa, right, besides that black box, and I'll get back to that. I wasn't just like against Iowa and I put a black box on it. But the whole Corn Belt and the Mississippi River Valley, right, the Central Valley of California, those are our real prime cropland areas within the United States. The other color I want to draw your attention to are kind of lighter green, you can see in like parts of eastern Texas, and then all that yellowish color, right, in the western US. That is our rangeland, right, range and pasture land in the US. And especially rangeland is too arid, too rocky, too steep for us to cultivate. Right? So there's really no way for us to generate human food off of that land base, which makes up 40% of the land area of the United States, the lower 48, without those four-legged critters, right? Cattle, sheep, and goats. So that's why ruminants are so important from a food system perspective, is that they're using things that we're not already using when it comes to crop production, right? And when I talk about enhancing ecosystems, if you can kind of see both enhancing and preserving ecosystems, in that part of south, kind of central Kansas, right, that's that yellow color. If you're not familiar with that part of the world, that's the tall grass prairie, right, that's left over. So it is fairly sad, right? Tall grass prairie used to stretch from Texas all the way up to Canada, all throughout Iowa, but it has all been plowed up, right? So the single largest contiguous area of that ecosystem left is in Kansas and in the Flint Hills and the Osage of Oklahoma. And one of the key reasons it hasn't been developed is because of cattle grazing, right? Actually keeping that system of grazing herbivore that used to be bison and still cattle plus fire is what actually keeps that ecosystem going. And when it comes to fire, this is where ruminants are important too. So you guys have heard a lot about the fire season this past year in the western US, and what's fairly clear from a lot of different research is that when we have landscapes that are unmanaged and we don't have herbivores removing some of the material, the grass, some of those wildfires can get larger and kind of out of control. They can have more fuel to burn, right? So that's where, again, grazing cattle and other ruminant animals in the western US can be helpful. So what about that black box over Iowa, right? What is going on there? So that's kind of my rough approximation of the area that is required of corn acres to actually feed cattle in the United States, beef cattle in the United States. So it's about 2% of cropland acres that are dedicated to corn that goes to beef cattle. And I put this up here because it's often this land competition issue that if we didn't use so much land for beef, we could be using it for something else, but that black box is really the area that is in competition. And as I told you earlier, we actually make more protein for the human food supply by taking that corn and running it through cattle, right, than if we were to eat the corn directly ourselves, right? Obviously, we can throw alternative crops on it, but just to kind of give you that idea of what is that land area that's truly cropland going for cattle production. So the third thing I'm going to talk to you guys about is how the U.S. compares globally. I kind of already highlighted that a little bit. And then how have things changed over time, right, in the United States for beef? So I showed you that box plot earlier that had all that variation in carbon footprints for beef. This is kind of a different way to display it, but as a map spread across the whole world. Okay? So this is a map from the Proceedings of the National Academies of Sciences, a paper that came out in 2013, looking at the carbon intensity of beef all over the world. Okay? So if you can see the scale at the bottom, the dark green, like in the United States, in Canada, Western Europe, that's where we have the lowest carbon footprints in the world. The lighter green, like in South America, that's where they're kind of intermediate. And then those purple areas are where we have the highest carbon footprints for beef in the world. So in those purple areas, we can have carbon footprints that are 10, 50, 100 times greater than here in the United States. Right? So it's tremendous variation. So why is that, right? Why is there so much variation? And I said earlier, it really comes down to live animals that are required to produce beef. So just to illustrate this, right, in the United States, we're the #1 beef producer in the world. Okay, so we produced last year around 26 billion pounds of beef. And we did so with a cattle herd of all beef and dairy cattle together of 94 million head. Okay? So that's a lot of cattle, right? But if you go down to South America, go to Brazil, they're the number 2 beef producer in the world. They produced around 21 billion pounds of beef last year, but they have a cattle herd of 220 million head. Okay? So they have twice as many cattle as us, but they make less beef. So what I told you about the methane gas earlier, right? Hopefully that begins to make sense. If you have more cattle, they live longer, right, to reach maturity. You have more cows, more bulls to support that herd. You're using more feed resources, your cattle are belching out more methane, your carbon footprint of that product is going to be higher, right, in those locations. So that's really what drives a lot of this variation. And this is not to put down other parts of the world, right? In parts of sub-Saharan Africa and obviously India, we have different cultural issues about why you might have a large cattle herd, or people that are keeping those animals more from like an equity standpoint rather than just production, right? So that drives a lot of those differences too. So I've talked about greenhouse gas emissions, but what's important is to always kind of zoom out and think about the bigger picture, right? How much greenhouse gas is actually coming from cattle within the United States relative to everything else? So the US EPA puts out a greenhouse gas emission inventory every year in April, and they look at all the different sectors of the economy and say, where are all these emissions coming from, right? From agriculture, from transportation, all the different things that we do as activities, right, as people. So from that EPA inventory, beef is around 2% of greenhouse gas emissions. These are the direct emissions that come from the cattle, belching of the methane from the manure, right? It's roughly equivalent to landfills, okay? So this is where sometimes when I give a presentation at dinner, I start really guilting people, right? Because the number one source of stuff that generates methane that goes into landfills is food waste, okay? So this is when we think about the whole food system where it really comes back to play of this kind of loop of nutrients that go through our whole food system. We produce a lot of food that nobody eats that never nourishes anyone in the United States, right? So we're never going to get that down to zero, but it is a pretty wasteful process. Beef, we waste around 20% of edible beef, which is a lot, right? Especially that life cycle of cattle. It may be 24 months from a cow getting pregnant to getting a steak to your plate, and then you're going to throw away part of it, right? So again, not to make you feel really bad, but kind of make you feel bad, right? When you throw food away, it's really a waste of a tremendous amount of resources. So in the United States, transportation and electricity represent a lot bigger portion of our greenhouse gas emissions. We drive a lot, we burn a lot of fossil fuels. All the lights in this room, plastic, everything takes fossil fuels to make. So that really dominates our greenhouse gas emissions in the United States. All of agriculture together, all crops, all animals, is about 90% of emissions in the US. So when you think about changes over time, and I'm giving you a beef example, but honestly we can extend this to all animal or all agriculture really in the United States in terms of changes over time. Productivity is really a key driver when it comes to sustainability. And so I'll use a historical example here to kind of illustrate that. So that chart I showed you several slides ago about kind of the availability of all these different meats, we peaked in the United States in terms of beef availability in 1976. So about 3 ounces per person per day. As we heard earlier, right, serving size, right? That was where we were at. And in 1976, we had 218 million Americans and 128 million head of cattle, and that's all beef and dairy cattle together. So fast forward to last year, we had 326 million Americans, so we gained over 100 million people in 40 years, which is kind of amazing. But our cattle herd shrunk to 94 million head, okay? Again, all beef and dairy cattle. And we produce enough beef for 1.8 ounces per person per day of boneless beef, accounting for all losses. So sometimes people look at that reduction in per capita availability and say, well, we've reduced emissions, right? But I just kind of give this example just to illustrate that's not that simple, right, in terms of how that works. So for example, if we produce enough beef in 2017 to still produce 1.8 ounces per person per day, but we did so with our technology and our efficiency back of the mid-70s, okay? We would still have a human population of 326 million people. We'd still produce 1.8 ounces per person per day, but we would have a cattle herd that's essentially the same size as the 70s, right? And the reason that is because we're essentially producing roughly the same amount of beef as we did back then, slightly a little bit more, but we're just spreading it out over more people's plates, if that makes sense, right? So per capita consumption is actually a pretty bad proxy from a sustainability standpoint of what's actually happening within the supply chain. Because all of our emissions, all of our impacts are happening mostly at the farm level. So with that said, I've kind of talked to you all about these greenhouse gas emissions, and if you all have questions about other topics, I know water is always important. I didn't put that in here this time, unfortunately. But we're missing other food system issues when we just focus on footprint differences across different foods, right? We're missing all those social aspects, the economic aspects, nutritional quality aspects, right? When we compare foods on a per kilo basis or per pound basis. So just to illustrate that, just to kind of come back to what I've already talked to you guys about, but it's really about the whole food system. And when I say system, you can kind of think about these different things that are on the screen, right? We have interactions between animal agriculture, here represented as cattle and beef, and plants agriculture, and us as human beings, right? What we actually use, whether it's for crops or for the animal products themselves. So manure is actually a really key organic fertilizer, right, for crop agriculture. So that's one way that those two aspects of agriculture interface. And obviously, cattle and other animals eat those crops, right? So there's that integration that takes place. It's not really either or. It's kind of about making those synergies between the two better. And there are obviously lots of ways where things that we eat, as I mentioned earlier, right, from sugar beet pulp to any of the processed foods that we eat, generate waste, generate byproducts, right, that usually end up going back to livestock feed. So again, there's that whole loop process. I just put this up here again to think about, is the whole system, not either or simplistic ways of thinking about it. So with that said, I think this study is a really good example of why it's a lot more complicated sometimes than it's made out to be. So this was a paper that was published about a year ago in the Proceedings of the National Academies of Sciences, looking at what if we were to take this concept that probably a lot of you have heard of, right, of like meatless Mondays, or trying to cut back on meat to cut greenhouse gas emissions. What if we took it to its most extreme level, right? What if everybody in the United States went vegan? And not just all the humans, but all the cats and dogs too, right? Like everybody is a vegan in the United States. And this is not against veganism or anything like that, right? But it's just more of a thought experiment of kind of going through what that would look like, okay? So what they found is indeed we would reduce greenhouse gas emissions by about 2.6 percentage points in the United States. And I kind of put in parentheses what that would be globally, right? It'd be less than 0.5% of global emissions. And then over on the chart, you don't have to read all the information, but really those two bars are just showing the current system and then what it would be in this world where we were all just based on plants, okay? The main takeaway is that you don't get the benefit of eliminating all the emissions from animals because you have to replace that manure fertilizer, right? You have to replace it with synthetic fertilizer, and there's a cost to that, and greenhouse gas emissions that get produced, for example. So the situation, you would reduce greenhouse gas emissions, you would produce more total calories, more pounds of food, but you wouldn't have enough micronutrients to actually nourish everybody in the United States, right? Especially, obviously, vitamin B12, which is pretty much 100% comes from animal source foods. And also, this assumes that all the livestock would disappear, right? So this is really key. We couldn't have any cattle in the United States to get this reduction. Right, so all 94 million head had to go away. No pigs, no chickens, nothing, right? So that's really important is, again, zooming out, sometimes differences between carbon footprints between foods exist, but you have to think about what does that practically mean, right, in terms of shifting the whole food system. I think this paper does a good job of kind of walking us through that. So with that said, I give you a lot of information, and hopefully I didn't go too much over time. But the takeaway is that sustainability is not about one production system over another, one pattern of eating over another, right? Any form of omnivorous eating or, again, vegetarian or vegan eating can be sustainable. It's more about making everything on the plate better over time, right? It's about that continuous improvement. That's what sustainability is about. So for beef, how we think about it, it's about producing safe, nutritious, high-quality beef, right, while balancing environmental stewardship, social responsibility and economic viability, right? Our producers had to stay in business to be sustainable, and people had to afford that food. So with that, thank you all very much for your attention. I'd be happy to take any questions if there's time, but also the website that's on the screen has a lot of our research information if you're interested in checking that out as well. So again, thank you very much.
Anybody have any questions?
If you want to know how you measure gassy cows, okay.
I'm just curious, what happened in the mid-1970s that made the big difference on the graphs? What were the factors?
Sure. Yeah, so I took some slides out, but the biggest driver has been the genetics of the cattle themselves. So you all watched Food Evolution last night, right? Genetic selection is incredibly important. We don't have any genetic engineering in the cattle industry, but it's just been more of the science of places like Iowa State University, where they have really good geneticists, of understanding why do animals perform differently. There's tremendous variation in the cattle industry, and still is, of feed conversion, right? How many pounds of feed does it take to make a pound of body weight gain? And so that's just one trait, for example, that producers measure and then understand which animals are better and select for that. And so over the course of many generations, that means we can produce more beef with fewer animals, right? So the animals themselves have gotten larger, they've gotten more efficient because of that selection. The other thing is the nutrition of the animals. So just like you all are professionals, we have professional animal nutritionists within the industry. So people that have PhDs in ruminant nutrition. And so they've really, over the last, especially the last 40 years, have understood what are the energy requirements, protein requirements, micronutrient requirements for cattle. And so we're feeding them just what they need to perform, not overfeeding them and creating an environmental issue, especially with nitrogen if we overfeed. Right, so those kind of things, along with just general health and management. So it's really genetics, nutrition, management of the animals, and then the general management, being better caretakers, better husbandry of the animals gets us there. Great question.
Okay, you were saying that a lot of the landfill greenhouse gas that's produced is from food, wasted food, okay. So is there a difference in the amount of greenhouse gas produced in a landfill versus, let's say, you compost your food waste in your backyard?
Yeah, so there will be a difference. So truly a compost system, not to get too technical in it, but composting, you're trying to infuse oxygen in the process. You're trying to have an aerobic process. So you will produce probably a little bit of methane. You're mostly going to be producing CO2, right? So if any of you all have had a food composter, right, you throw a whole bunch of stuff in there and then you get like this little amount of stuff out, and you're like, where did it all go, right? It came off as gas, and plus it was a lot of different water that was actually in there. So yeah, composting tends to lower emissions. Methane gets produced when there's oxygen-free environments. So a landfill, and you have a tremendous amount of mass going into it, it gets covered up, right? It produces a lot of methane gas, and that's, everybody's familiar with seeing a landfill and having the pipes come up out of the ground, right? That's letting that gas off, and oftentimes you'll see a landfill, somebody will have a flare going, right? They're burning the biogas that's coming off. There are ways to actually capture that and try to use it in a positive way, right? Burning it is actually, it seems like it would be bad, but if you're taking methane and you're reducing it to CO, or oxidizing it actually to CO2, you're lowering the greenhouse gas warming effect of that gas. So there's lots of different things we can do, but trying to generate biogas to use it for eating, running a boiler, doing things like that, are other ways that we can kind of get around this realization that we're never going to eliminate waste, but how can we use that waste better instead of just throwing it out of sight, out of mind, and creating a problem, right? Which is a lot of what we do, unfortunately, in our society. We just throw stuff away. Yep.
catch exactly the difference between grain-fed and grass-fed beef. Can you explain, is there a nutritional difference?
Yeah, so nutritionally, they're, and I'll let, our beef council representative, Rochelle, she probably has the fact sheet where we kind of look at the comparison. The short answer is, in terms of an effect in you as a person, a biological effect, there's no difference, right? There tends to be a difference in flavor profile, and that really comes down to the amount of fat and the certain types of fatty acids that are in that beef, because that does depend on what you feed animals. And sometimes we oversimplify this, that there is a tremendous amount of variation in what people feed cattle, even in the finishing phase for grain-based, and so that could change the fatty acid profile slightly. But just if you do the math on some of the differences between omega-3s, between the two, you would just have to eat so much beef. I mean, I say this as somebody that works for the beef industry, right? You would have to eat so much beef, but they're like, no, don't eat that much beef to get that nutritional difference, right? As we say, if you want to get a good source of omega-3s, think about flaxseed or cold water fishes, right? I mean, that's going to be your better source of omega-3s is beef, regardless of how it's finished. It's more of like, it's a choice. And some people prefer grass finished, and that's awesome, right? And that exists out there for people to choose. So I did get a question up front here too about how do you measure the gas, right? So you all are familiar with the idea of indirect calorimetry, right? It's the same thing. The only difference is that with cattle, we add methane, right? So we measure oxygen, CO2, and methane fluxes, and then we can calculate like the energy balance of cattle from that. It's just a lot of engineering / bioenergetics to do it.
Okay, that slide that showed the carbon footprint of all the different animals. Now, was that on a was that on a per weight basis, on an animal basis, or is that like the world conglomerate?
Yeah, a few of those things together. So this slide is showing you kilograms of carbon dioxide equivalents per kilogram of protein being produced for these different animal proteins. And the reason I use this slide is because it is from a single source, and the methodology is the same across all the species. And that's our other challenge in the space, not to bore you, but everybody uses a slightly different method to measure some of these things, and it makes it incomparable, right, to actually look at. And so that's why I like to use this, because it is all the same methodology. However, it is a global average, right? So again, for beef in the United States, we're off the bottom of that 10%, right, in terms of the bottom of the 90% bar, like that's where we are, right, in the world. So mainly that just highlights there's a lot of room for improvement for beef globally, right, in terms of reducing emissions. Yep. Okay, thank you very much. I really appreciate it.